Since 2011, the Russian energy corporation, Gazprom, and a group of large investors have been working on one of the longest and highest capacity offshore gas pipelines in the world. The Nord Stream 2 is a pair of large-diameter natural gas pipelines running along the bottom of the Baltic Sea from the Russian coast near St. Petersburg to the northern coast of Germany near Greifswald. Planning, design, and construction of Nord Stream 2 was mired in political controversy not only because of climate-related apprehensions over new fossil fuel infrastructure, but also over concerns that the pipeline could be used as a geopolitical weapon by Russia against other European countries. Still, construction began in 2016 and finished 5 years later at the end of 2021. As the German government worked towards certifying the pipeline to begin operation, Russia launched a military invasion of Ukraine. This unjustified and unconscionable attack on a sovereign nation has received widespread international condemnation, followed up with a litany of sanctions on Russia and its most senior leaders. Part of the response included Germany halting the certification of this divisive $10 billion mega-project as of this video's production. The invasion of Ukraine is ongoing, and future international relations between Russia and most of the developed world are unlikely to improve anytime soon. The U.S. put sanctions on the company in charge of the pipeline and its senior officers. The project's website has been taken offline and most of the employees have been fired or quit. These circumstances raise plenty of questions. How do you install a pipeline at the bottom of the Baltic Sea? Why is this line so important to geopolitics? And what does the future hold for what may be the world's most controversial infrastructure project? In today's video, we're talking about the Nord Stream 2 pipeline. Like its predecessor, Nord Stream, the goal of the Nord Stream 2 pipeline is to provide a direct connection between the vast reserves of natural gas in Russia and the energy-hungry markets of Europe. With a length of 1,230 kilometers or 764 miles each, the twin pipes pass through the territorial waters or economic exclusion zones of 5 countries, TE2 landfall nations of Russia and Germany, as well as Finland, Sweden, and Denmark. Also, like its predecessor, the Nord Stream 2 is owned by a subsidiary of Gazprom, a Russian state-owned enterprise and one of the largest companies in the world, and financed by a coterie of other international oil and gas firms. The project has a long, complex, and controversial history. This video is meant to highlight the engineering details of the project, but in this case, the politics can't be ignored. Even before construction began, Nord Stream 2 had some massive obstacles to overcome. The Baltic is one of the world's most polluted seas, and all the countries around it have a vested interest in making sure those conditions don't worsen. Pipeline construction can create harmful levels of underwater noise, affect fisheries, disrupt water quality, and even impact the cultural heritage of shipwrecks along the seafloor. Each country along the route imposed strict environmental requirements before construction permits would be issued. The planning phase for the pipeline involved detailed underwater surveys of the seabed to help choose the most feasible route along the way. This survey also helped identify an exploded ordnance from World Wars I and II. Where possible, the pipeline was routed around these munitions, but in some cases they had to be detonated in place. When this was done, the contractors used bubble curtains around each explosion to mitigate the noise impacts on marine life. The logistics of producing so much pipe was also a huge challenge. The pipe sections used for the Nord Stream 2 were about 1150 millimeters, or 45 inches in diameter, and 12 meters or 40 feet long. They started out as steel plates that were rolled into pipe sections, welded, stretched, beveled, and inspected for quality and interior epoxy. And the friction coating was applied to minimize the pressure losses. In the extremely long line, then an exterior coating was applied to protect against corrosion in the harsh saltwater environment. And the entire project required manufacture of more than 200,000 of these pipe sections. That's an average production rate of nearly 100 pipe sections per day spread between 3 suppliers. Each pipe section was transported by rail to a port in Finland or Germany to receive another exterior coating, this time of concrete. The concrete would help resist the buoyancy and underwater currents that can move the line over time. It also provided mechanical protection during handling transport pipe play and for long-term exposure along the seabed. After weight coating, the pipes were shipped to storage yards along the coast where they would eventually be transported by ship. 2 large pipelay vessels working in the Baltic Sea. These pipelay vessels were floating factories, employing hundreds of workers each. And the Nord Stream 2 project had up to 5 working simultaneously on the largest vessels. The basic process for pipe laying was first to weld 2 pipe sections together to create what's called a double joint. These welds got a detailed inspection, and if they passed the double joint, moved to a central assembly line to be connected to the main pipe stream. There you got more welding and inspection. If everything checked out, a heat shrink sleeve was placed around each weld, and then polyurethane foam poured into a mold between the concrete coatings to further protect against corrosion, while allowing the pipe string to flex during placement. Once complete, the vessel could advance a little further along the route while lowering the pipeline into its final position. This was a 24/7 operation, and some of these pipelay vessels could complete 3 kilometers in a day. In many locations, they could just lay pipe directly on the seabed. It was smooth enough to keep the line from deflecting too much and soft enough to avoid damage to the pipes. However, that wasn't the case along the entire route. In some shallow waters where the pipelines were exposed to hydrodynamic forces like waves and currents, the lines were placed in excavated trenches and backfilled. There were also many areas along the route that were rugged enough to create free spans of unsupported pipeline. Fall pipe vessels were deployed ahead of the pipe installation to fill depressions with rock and gravel to provide a smoother path along the seabed for the line. Finally, at location where the Nord Stream 2 lines would cross other subsea cables or pipes like power, telecommunications cables and other pipe lines, rock mattresses were installed to protect each utility at the intersection. In conclusion, the Nord Stream 2 pipeline linking Russian natural gas to Europe has been finished after a 5-year construction period, though Germany has paused it due to Russia's military invasion of Ukraine and resulting sanctions.